respectively, they have their colors. So let's say that we want to find the probability of, say for example, a full house. So let's say that we want to find the probability of a full house. Well, one thing that you would have to realize is that it's essentially that you have three of the same card and two of the same of another. Okay, so let's say that we want to find how we can do the probability of a full house. Well, the probability of a full house is as follows. So we're going to have to be very specific in how we find this. So this is going to equal to, let's use this black pen and change it to a gray. Okay, so we have that this is going to be equal to, well, we have to think of what number of ways can we get a full house. So the way that we can do this is that we have to think, well, let's first find the first card that we want to have three of the same. So that would be combination 13 choose 1 multiplied by, well, we need to pick, say for example we pick a 2, but then we need the 3, so that's going to be times the combination 4 choose 3 multiplied by, well, now we need another card, so we have that we need to select another card. But to do that, we're just going to say, well, that's just going to be combination 12 choose 1, because we're just selecting the other card that's different. So that's going to be 12 choose 1 multiplied by, well, how many do we need? We need that there's going to be 4 and that we're going to select 2. Okay, so that means that the probability of a full house, and let's just go ahead and reiterate this, this is the respective first card to be matched. And then these are the 3 matches. And then this right here is the second card. That's the second card that's going to be matched. But then these are the 2 that will match. Okay, so we know that this is going to be equal to, if we do that computation, well, using your calculator, you're going to find that this is all equal to 3,744, but all of this is divided by, and we should probably just make note that we didn't divide the total number of ways that we can collect a group of 5 cards. So we have combination 52 choose 5. Now this is going to be equal to, okay, so we just need to say, well, let's actually go ahead and just say that we'll go ahead and just find what the number of ways that we can select the 5 cards from the 52. So that's going to be 3,744. Let me just do this really quick. 3,744, all divided by the number of ways that we can select 5 cards from 52. So that's going to be 2,598, and that's going to be 60, well, you're going to get that that's going to be 0.00 144. Now, what that means is that essentially that there's a very small chance of getting a full house. So that's going to be 0.144%. Okay, so that's going to answer the question as to what is the probability that you get a full house. Now, what if we were to do another example? Say we want to know the probability of two pairs. Now, keep in mind that we're playing a game of poker, hypothetically, and that if we want two pairs, we mean that we can have two twos and then anything else that doesn't match. So we're going to say that the probability of finding two pairs, we have to find the number of ways that we can match two pairs. So we'll do it like this. How about we say that E is the event of two pairs. Now, we're just going to say that in order to find the two that we're going to match, we're going to say it like this. We'll take 13, choose 2, and that will represent the card that will be matched. Okay, so we have that we're just going to pick two cards that are going to be matched. So for that, we need to multiply. So we're just going to multiply by 4 choose 2, because one of the cards needs to be chosen where you're selecting both of them. So like if I select a 3, then I need 2 3s. So that's going to be the match. And we'll just say the first pair. But then we also have that this is going to be multiplied by, well, similarly, the second pair to be matched. So we have that's going to be that. And we'll just put second pair. Now, this is key right here. If we're going to select a two cards of which will be matched, that makes 4. But then we need to account for, well, that's that other card that we'll have that we need to pick. So that's going to be multiplied by combination. Well, we need to account for that we have 8 cards total that need to be removed. So that's going to be 52 minus 44, or 52 minus 8, which is 44. And we're only going to pick one card. Now, what you'll find is that when you multiply across using your calculator, you're going to find that that's 123,552. Now, all of this has to be divided by the total number of ways that you can have a matching pair. So all of this is divided by the 2.598,960. And when you do this computation, basically you're going to find that this gives you approximately 4.75%. So we can actually, multiply this by 100, and you'll find that that's equal to about 4.75%, which tells you that you have a higher chance of getting a you have a higher chance of getting a two pairs. Now, the other thing that I can look at, for example, is what happens if I only have, let's say, one pair. So if I look at one pair, then that could be another, possible question when dealing with probabilities and cards. So let's say that we look at the probability of one pair. Well, the probability of one pair is essentially just like saying that, well, let's say that we have a 3, and then followed by maybe like a jack, a 6, and then maybe like a 10. Well, we can't have any other matching cards. So what that means is that we just need to figure out what are the total number of ways that we can find a pair. So the way that I'll do this is that I'll just say, well, I need to pick one card that's going to be matched. So 13 choose 1 multiplied by the two cards that need to be matched. So if I select a 3, I need another 3. So that's 4 choose 2 multiplied by, well, now I need to select 3 cards from my 13. So we'll just do that. We're going to select 12 choose 3. Why is it 12 choose 3? It's 12 choose 3 because if we chose a card from the get-go, we need to remove it from the 13. So that's why we have 12 instead of 13. But now we need to select just one suit each. So that's going to be multiplied by combination 4 choose 1. Now that only accounts for just one card of the 3. So in that case, we can just cube this and just say that that's going to be accounting for the respective suit. So like if I have Jack of Hearts, 6 of Clubs, and 10 of Spades, that's going to be accounted by this last number right here. So if we look at this computation, we can figure out what this will equal. So we find out that that's going to be equal to 13 multiplied by 6 multiplied by 220 multiplied by, well, 4 cubed is really just 64, so we have 64. Now that equals to 1,098,200 298,000 and 240. So that means that the probability of one pair is equal to our million ways that we can get one pair, all divided by the total of 2,598,960. Okay, so that's going to tell me that that probability is going to be approximately, okay, so that's going to be approximately, okay, so that's going to be 42.2569%. So that means that there's a really high chance that you get one pair at best. Now, I can do the same thing for, like royal flushes and whatnot. Um, or I can do the same thing for like three of a kind. That means that you have 3 cards with 2 throwaways. So I would say, just try to see, like if you can do some of the examples where you try to find, the probability of 3 of a kind, which I'll put the answer, that the answer is 2.1128%. And then royal flush, the probability of a royal flush is it's very low. So you have that that's going to be 0.000 154%. Now consider this, that those that do card counting, that's very impressive, and it's only with regard to just like one deck of cards. So imagine those that really do it in like casinos, then in that case, there's more than one deck that's being used. Now, one thing that you have to note as you're kind of working out these problems is that the hands that we were doing was poker. So you just have to make note that poker uses five dealt cards. Okay, so in that case, like you just have to remember that with the poker, you have that 52 choose 5 is equal to the 2,000,000 598,000 and then 960. Okay, so make sure that you look at some of these problems and try to see, like, can you do some of the computations, because there are a lot of different types of hands that exist in poker. We only did the full house, the two pairs, and the one pair. So try the royal flush and maybe even the three of a kind and see like what you can get. You can also do four of a kind if you want, and it's going to be like more or less the same process.